Thank you very much for joining this webinar of Project Sustain 6G, which will be about sustainability in 6G, about needs, methodologies, and vertical integration. It is an activity or a work that has been performed in the project called Sustain 6G, which is the Sustainability Lighthouse of the SNS JU program. I have one slide about the whole project, and I don't want to spend any time really on the project itself because the scope is quite wide. I'm only displaying here that we have a fairly large consortium dealing with the issue across the different facets of the sustainability needs and requirements, and we will hear a lot of that from the different presentations that we have scheduled today. Now, the scope of the webinar is obviously to do some recap of where we need some alignment on sustainability topics and aspects, or whatever other word we are using, in fact, to describe the scope of the work in this project and in general in the ICT industry concerning sustainability. Then we'll give a glance on research and methodologies ongoing, the collaborative framework that we are setting up, and more importantly, to provide a kind of a triple perspective from a telecom operator point of view, a technology provider point of view, and obviously from a customer point of view, which for our case, it's typically stakeholders from the vertical sectors. Now, the agenda has been published when you registered, and I just repeat it here for completeness. So I'm almost done with the initial part of the agenda, so the prologue introduction. Then we will hear about sustainability terminology and needs by Maria Martin-Minko-Blue from University of Oulu. We'll share a telco perspective that will be provided to you by Berna Serak from Orange, a technology perspective from Nokia Bell Labs from Dominic Charoni, which is expert on optical networking, and then the customer perspective from Daniel Hawa, Siemens. We will conclude with summary and recommendations by Socrates Pavnakis, Senior Project Manager at Wings ICT, and then we have provided sufficient time at the end for Q&A. Again, I repeat, please share your comments and questions in the chat, and I will try to dispatch them at the appropriate point in time. So then, without losing more time, I am actually 1 minute over. I would like to give the floor directly to our first speaker, who is Maria Martin-Minko-Blue from the University of Oulu. Maria, the floor is yours.
Thank you. So my name is Maria Martin-Minko-Blue, and I am in this Sustain 6G project as one of the task leaders, task 2.3 lead, and that is about sustainability needs and requirements. And I will briefly tell about the work we are doing right now and emphasize the certain terminology that we have already developed in the project. So let's start with this, sustainability pillars. And I think when I saw the list of participants, I thought that many of you are familiar with these basic sustainability pillars that we are addressing in the Sustain 6G project when it comes to sustainability in the context of information and communication technologies, and especially future 6G systems. Economic sustainability, social sustainability, and environmental sustainability. They have been included in the ICT discussions as the 3 pillars, and they are tightly interlinked. They are like lenses to structure the whole sustainability debate, but then they are very much interrelated, like economic aspects drive the societies, social sustainability depends on many things, environmental sustainability also is very much interlinked. So they are like the viewpoints which have many interrelations. Those 3 pillars is what we consider in the project. Then the other side of the sustainability part is what we call as sustainability aspects. And they are sustainable 6G and 6G for sustainability. those two different perspectives in terms of what are we talking about? Are we talking about the ICT technology itself, or then the use of that technology? We had very intense discussions about the terminology, and I think that's the big starting point for any interdisciplinary research project, that we have to create a shared understanding of what we mean with the key terms. What are the key terms, and then what we mean with the key terms. And there's a lot of literature available about all the terms, but then it's always important that the people come together and decide that in our context, this is what the key terms mean. So this economic, social, and environmental sustainability and sustainable 60 and 64 sustainability, they result in 6 sustainability dimensions. And this is what the project is considering. And I've understood that also many of the 60 R&D projects, they consider these parts. We call them 6 sustainability dimensions. And then we moved on to think about, when we were discussing that, what do we mean with this concept? We haven't defined everything yet. We are now in month 9 of the project, and it takes time to create shared understanding. But what we concluded is that we are not talking about handprint or footprint, since they are challenging terms. We decided that in Sustain 60, the terminology that we're using then is first order effects and second order effects. And what we mean with these, they've been defined primarily in the context of environmental sustainability in the ICT sector. We've broadened that scope to consider also economic and societal effects. So first order effects are the direct economic, societal, or environmental effects associated with the existence of an ICT-based solution. That's the generic term. So first order effects are related to that ICT solution and its existence. Then they could be positive or negative, and they are stakeholder dependent. And examples of this are raw material acquisition, production, use, and end-of-life treatment stages of products, and so on. Then the other side of this coin is the second order effects. And that is the effect induced by the use of that ICT solution. And that includes economic, societal, and environmental changes, which again can be positive or negative for a stakeholder. And one stakeholder can perceive something as positive, while another one sees something as a negative. So that's the distinction that we wanted to make. First order effects are the direct effects, economic, social, societal, and environmental effects from that existence of the ICT solution. Second order effects are the effects, again considering economic, social, and environmental sides, from the use and application of the ICT solution. And these are, they still are confusing. Still many months into the project, we still struggle to remember what they mean, but that's what we try to have this. I'm saying this now many times to you in this webinar because it takes time to adopt the thing. First order effects, the direct effects from the existence of the ICT solution. Second order effects, the effects from the use of that ICT solution. I guess I've now spent enough time on that part, so let's move on. Then the SNSJU project, 60 projects, they often consider key values, KVIs. That's the buzzword that everybody is talking about. We have defined key values as the principles or qualities that individuals or groups deem important, desirable, or intrinsically good that may be addressed or impacted by ICT. And this has the whole perspective that they are values that individuals or group deem important. And they're different to different stakeholders. The original paper by the 6GIA's SNVC subworking group had the KVI paper in the Telecommunications Policy Journal, and they had we had the white paper as well. And there we used the terms values as criteria, values as outcomes. And we had very intense discussions in the project about these and decided not to use this distinction. We're not talking about this anymore in that project. We talk about key values that are the principles or qualities that individuals or groups deem important, desirable, or intrinsically good. Then we did a quite extensive state-of-the-art collection because a lot of material is there from the different stakeholders, companies, forums, policymakers, a lot of standards, documents, and so on. So we did this kind of document analysis, and then we went within the ICT context, sustainability and the ICT context, and then we analyzed them that what kind of environmental, social, economic topics we can identify there, key concerns, effects, themes, considering the first and second order effects. And then we made a quite extensive analysis of that. This is an extract of that, just highlighting some of the things. And we used this categorization: environmental, social, economic sustainability, first order effects, second order effects. So that is now the classification and terminology that we've developed in the project for our classification of topics, noting that they are tightly interlinked, noting that it might be difficult to characterize something to be a first order effect or a second order effect, because they're not completely established what goes where. But in any case, examples of first order effects in the environmental sustainability pillar are the greenhouse gas emissions, energy consumption, resource consumption. Examples of second order environmental sustainability effects then could be changes in the greenhouse gas emissions through user behavioral changes or changes in the energy consumption. Social sustainability then could have security, privacy related things, improved leisure time, better, more accessible services, and so on. And here also the societal acceptance is very important. These are just examples, so this is not an exhaustive list. When we went through the analysis, there was a lot of material there. Business economic sustainability often considers costs from the new technology. Somebody needs to invest in that. There might be increased operational costs if we have very strict environmental sustainability requirements and so on. Second order economic sustainability effects could include efficiency, productivity gains when we're using the ICT solution, because the second order effect is from the use of that ICT solution. So we could, so I say resources there, that could also lead to reduced greenhouse gas emissions and money savings and so on. So that's a kind of short summary of what kind of themes we have considered. Then I go back to these key values, KVIs, since they are so important, and that's the definition we did. And then KVIs, everybody talks about them. We've defined KVIs as the qualitative assessment or quantitative metric used to observe the extent to which first order effects and second order effects align with the identified key values. So our KVI definition then brings together first and second order effects and how they align with key values. And key values then are what is the principles or qualities that individuals or groups deem important. And I have two highlights here about these. Key values are always stakeholder specific. Therefore, the stakeholder perspective is extremely important, especially around sustainability thinking. Different stakeholders might have very, very conflicting ideas about what is intrinsically good from their perspective. KVIs, on the other hand, they are qualitative assessments or quantitative metrics. They are not always quantitative. They are not always calculated. So our sincere wish is that we could get away from this measuring KVIs, calculating KVIs, simulating KVIs. It's okay that they could be also qualitative assessments. Many times qualitative assessments can provide very valuable information compared to a number, which might not necessarily describe the actual phenomena well. So that's the takeaway from this part, that key values are stakeholder specific. KVIs could be quantitative metrics, but not necessarily. So let's not have a fixed mindset that it's always quantitative. They're not always quantitative and they're not always calculated. So what happens next? We're developing the sustainability requirements definition methodology in the project. So how to derive sustainability requirements. We have a flow for that, and we're now trying that out with certain use case specific examples. And also developing the relationship between the key concepts. We're still defining some of the terms. Not everything is defined. But worse yet, or not worse, but more challenging yet, what are the connections between sustainability needs, key values, KVIs, sustainability requirements, and so on? That's what we're now working on next. I want to remind here, you will hear it later on, that Sustain 6G published deliverable lead 2.1, and it has a lot of sustainability discussion already in it. So that was published in June, and that's the first public deliverable that you can find more information. I end here and I hand over back to Tassos.
Yes, thank you very much, Maria. I would like to invite now Berna Sayrak from Orange to give us the telco, so the telecom operator perspective on sustainability. So Berna, the floor is yours.
Okay, thank you very much for this opportunity. In Sustain 6G, I'm Berna Sayrak from Orange. I'm a task leader in Sustain 6G in Work Package 6, but here today I'll present you a telco perspective, a mobile network operator perspective on sustainable 6G. Our focus is on public mobile networks for a sustainable consumer market. So we're addressing 6G for sustainability and sustainable 6G, as Maria has just presented. So this is a proposal led by Orange, but contributions from the other two telco operators of the consortium, DT and TIM. So I'll start with the context and motivation. Well, Sustain 6G has vertical use cases that we'll see in later presentations, but 6G market will be mainly driven by the public mobile networks. That's why it's very important to add a transversal perspective containing public mobile networks to the picture, and that's the purpose of this use case, transversal use case on public mobile networks. Well, we know that ICT sector is contributing to an environmental impact on GHG emissions, on carbon dioxide emissions, and it's quantified as 4% approximately. It may be small, but it's growing 6% per year, and the growth is increasing by factors such as AI, for example. And the networks and infrastructures constitute 1/4 of these emissions. And we know that most major ICT actors and European mobile network operators have committed to net zero GHG, greenhouse gas emissions in the 2040 time horizon. And in 2040, 6G will have been already deployed. So we think that 6G has a word and a role in this reduction of the GHG emissions. But at the same time, this is very challenging because the economical viability of the business should be kept. And also adding value to the society is a motivation for all the European mobile network operators. For example, a typical value to the society is digital inclusion. With all these elements of context, we are motivated to propose a transversal use case on public mobile networks with an MNO perspective. Well, the sustainability objectives currently of the MNOs go well beyond the carbon emission reduction. So we need to reduce the energy consumption. We need to have digital inclusion, so including underserved populations of the world. And we also need to have a sustainable business. And these all have to be achieved simultaneously, which is not at all a trivial task. So we are facing conflicting sustainability objectives. across all phases of the networks: design, deployment, run phase, and end of life as well. For example, we are trying to reduce our GHG emissions and maintain business viability and performance differentiation. However, the current volume growth models often conflict with environmental sustainability goals. So we have a clear conflict here. We try to extend the equipment lifetime, but we also need to have competitive renewal cycles and sometimes aggressive rollout to carry the traffic demand, which is creating revenues for all the value chain. We try to find a solution to digital inclusion with non-terrestrial networks, but they have very high environmental impact in terms of greenhouse gas emissions and also waste. We also have a data challenge on reporting and traceability of sustainability data across the value chain. Reporting also is a big challenge, so standardized and transparent reporting across all the value chain is necessary. That is mainly the reason for initiatives like CSRT or European Code of Conduct for Telecom Sustainability or Science-Based Target Initiatives. So we need to find trade-offs and reconcile those conflicting sustainability objectives across all the life cycle phases and across all the value chain. The stakeholder perspective should be also taken into account with a proper use of reporting and data. So that's why we started with an exercise to define a transversal use case that we have called the MNO perspective, and try to look at the key values on the 3 sustainability pillars, taking into account both sustainable 6G, so the direct impacts, and 6G for sustainability, induced or indirect impacts, like Maria has just presented. So on the environmental sustainability case, we have the typical key values like reduction of greenhouse gas emissions that were just presented, including all the scopes 1, 2, and 3, limiting energy consumption, biodiversity, natural resources, minimizing e-waste, and of course pollution. So these are all the reduction of negative impacts on the environment by the networks and infrastructures. On the economical sustainability pillar, we have the sustainable economic viability of all the sector, including all the stakeholders, revenues, increasing revenues or increasing the profit margin, job creation, employment. This is a value also for the societal pillar, investment capacity, costs, affordability of the ICT solutions are among the most important values on the economical pillar. And on the social sustainability pillar, we have values like digital inclusion, trust, confidentiality, resilience, privacy, dignity, transparency. These are all important values for the society that are expected to be provided by the public mobile networks. Also employment capacity and respect of human rights across the entire value chain. For example, child labor or working ethics conditions during the especially during the extraction mining phase of the life cycle. So the previous picture was a more holistic picture, but as a starting point, we have decided to take into account, because we would like to evaluate and show the trade-offs of those conflicting key values. And in order to have a first step for a feasibility point of view, we have tried to take a reduced set of KPIs. So this is the first step, the starting point. And once we know the methodology, because we are defining also an evaluation methodology framework, and once we know how to evaluate and validate the methodology, we can include one by one the other KPIs. On environmental sustainability, the major point is reduction of GHG emissions on the public mobile networks, including all the scopes. This is in accordance with the UN Sustainable Development Goal number 13, climate action, and we have identified and the possible levers and solutions are already identified: lifetime extension, circularity principles, sharing, hardware, software decoupling, energy efficiency, etc. On the economical sustainability, we have chosen the economic business viability of the telecommunications sector, which is in line with the UN SDG number 8 on decent work and economic growth, and also number 9, industry, innovation and infrastructure. And here we have possible levers, solutions as a cost reduction, different marketing strategies, new revenue sources, etc. And on social sustainability, we have chosen as the first key value, sustainable employment capacity of the telecommunications sector, which is very much in line with the economical sustainability indicator, aligned with the UN SDGs number 8 and 9, and the possible levers are very much similar with the second pillar. This is a first attempt on the sustainability impact analysis on first and second order effects on the 3 pillars. This is quite a list, but we have highlighted in red the most important effects that we will consider as a first step, and then we will try to include the other values, other effects on the key values, whether it be first or second order. Here we see on the environmental side, the most important major effect is climate change through GHG emissions. The economic side, the ICT solution cost, total cost of ownership. On the societal side, the capacity of the ICT sector for job opportunities, so employment to the society, on the whole value chain. And for the ecosystem, this is an ongoing work, we are defining the stakeholder ecosystem. We have already identified 3 groups, 3 categories: the provisioning actors, all the actors that provide the ICT solution. So the mobile network operators, equipment suppliers, integrators, platforms, data centers and cloud providers, testing and measurement, industry associations and research. The second one is on end users, so that are creating the demand, the consumers, public sector, every third-party users are included as well, and the enablers, policymakers, rule makers, standardization bodies, funding agencies, everything related to finance, patent offices, and etc. The technical baseline of the evaluation will be the IMT 2030 framework, which is the 6G basis, technical basis in terms of capabilities, requirements, and spectrum. We are considering nationwide deployments as public mobile networks, so basically macro base stations with varied antenna configurations, and the environments vary from dense urban to rural, and typical MNO subscription volumes. There's a critical need on sustainability data across the value chain in order to be able to evaluate the trade-offs on this use case. And as for the next steps, we are now consolidating the needs, key values, key valuing indicators, and requirements for all the stakeholders that we are identifying. And also in parallel, we are working on an evaluation assessment methodology framework that will take into account the key value indicators and come up with assessment on first and second order impacts to show the trade-offs on these conflicting values, effects that I've tried to present. So that's all from my side, and I give the floor back to Tassos.
Thank you very much, Berna. That's indeed very insightful. Thank you very much, Berna. And we can now continue with our next speaker, who will provide us a technology perspective, so a technology provider perspective. That will be Dominic Ciaroni from Nokia Bell Labs.
Thank you so much. Thank you so much for your kind introduction. So good afternoon, everybody, and thanks for giving us this opportunity to present this work. So this presentation that addresses needs, methodology, and vertical integration will be now focused on the tech perspective. I take this opportunity also to thank all the contributors of this part of the deliverable, in particular D2.1, particularly Anastasius, Gavras, the Work Package 2 leader, and Socrates, also Bampounakis, the editor of the deliverable 2.1. Let me jump on the next slide. So on this slide, we list the points that will be addressed in this presentation. We will start with a recall of the Sustained CG project objectives, and then address the business model evolution. After a recall of the sustainability by design definition, we will propose an inclusive eco-design approach in a sustainable context. We will see how we can minimize the energy consumption of future products. Finally, we will draw a conclusion. So this slide recalled the Sustained CG project objectives. To create impact, the project will address technology enablers for sustainable SIG, the focus of this presentation, SIG for sustainability applications, the focus of the next presentation, and the validation, evaluation, integration, and testing that was presented just previously. Okay, so this slide shows the evolution of the business model to better understand the new needs. If a few decades ago, the model was mainly driven by the business, with little consideration for environmental and societal criteria, the energy crisis and the climate change force industrials go into an eco-design approach with an equal contribution of business, environmental, and societal criteria. But the main driver was the speed and the capacity to provide a high quality of service to end users. Very recently, the sustainable approach changed the game and modified the business model through an inclusive approach, including strong environmental constraints, plus societal and economic criteria pushed by clients, stakeholders, and end users. We are entering into a pull market phase with a strong Scope 3 objective to reach by 2030, a shift from speed to quality of experience at the end user level, and a long-term approach for a positive societal and economic vision. So the sustainability by design becomes then a duty for future products. Sustainability by design means adopt key value indicators and key performance indicators to identify an absolute optimized product solution. The figure on the left side summarizes an example of proposal for the sustainable design of a solution. We start from the use case or from a network segment. The list of requirements targets key performance and key values before the identification of key performance indicators and key value indicators for a quantification or a qualification of the solution. Then we have to design the solution. To do this, we adopt eco-design rules on the top of a solution that must respect environmental, societal, and economic criteria. To build this solution, we need to identify then key technology enablers and to adopt them when possible. We outcome then with a proposed solution that needs to be evaluated through a comparison with the key performance and key value indicators. After several loops, we converge towards an optimal solution. Note that we need also to take into account the physical limits of some technologies and have an heterogeneous approach. For some network segments, we need also to take into account interdependencies between subsegments for an optimal process. In the next step, we will be focused on the eco-design phase. So this slide describes an inclusive eco-design approach in a sustainable context. On the left side, we can read some important eco-design rules. Life cycle assessment, minimize resource use, design for durability, design for disassembly, adopt clean production techniques, optimize packaging, design for energy savings, plan for end of life, avoid hazardous substances, comply with environmental standards. If we do a zoom on the minimization of the resource use, we can identify two directions. To reduce electricity demand, we can associate renewable energies coupled with an energy storage and controlled by an energy management system. To limit wasted energies, we can adopt energy conversions, or we can exploit these wasted energies for societal and economic purposes. This is the case, for example, for data centers, offering a transport of thermal energy to heat thousands of homes. So this slide does zoom on the design for energy savings. In that case, we have to distinguish the primary key technology enablers from the secondary key technology enablers. The primary list will structure the technical solution through the adoption of structuring technologies. The secondary list will provide complementary technologies that can be put on the top of the primary technologies. For the long list of key technology enablers covering all the layers of a network, we can list cloud-native sustainability, artificial intelligence, societal and economic sustainability, eco-software, energy-efficient orchestration, energy-aware Kubernetes, eco-management, channel symbol shutdown, sleeping modes, power management, and so many others. So we recall here the Kubernetes, also as known as K8s, is an open source container orchestration system for automating software deployment, scaling, and management. Originally designed by Google, the project is now maintained by a worldwide community of contributors, and the trademark is held by the Cloud Native Computing Foundation. Excuse me. So this slide shows one example of a key technology, to be more explicit, illustrating here a transmission system. The primary technology can be a wireless system or an optical system. For example, in the optical system at the transmitter level, we can adopt high energy efficient lasers, like vertical surface cavity emitting lasers that can offer energy efficiency as high as 100 femtojoules per bit for some application, for sure only. We can adopt WDM transceivers to slow down the frequency by exploiting an optical parallelism. We can adopt bit interleaving when we want to reduce the frequency processing of the electronic detection. We can also adopt low power consuming device, etc. So the list is quite long. For the wireless part, we can adopt low power consumption modulators, sleeping modes, zero traffic, zero power, power scaling per antenna, etc. This is an example focusing the technical choices on the physical layer. This is a second example from the state of the art, recalling the key results of the Green Touch project. The primary technology adopted was a passive optical network for the fixed access part. The motivation is illustrated in a central figure, showing that this primary technology can reduce by up to 82% the energy consumption of a passive optical LAN configuration when compared to a classical Ethernet LAN. These results were obtained by the University of Melbourne. The figure on the right side of this slide shows the different secondary key technology enablers to increase again the energy savings. What is interesting is that the primary technology has interesting perspectives projected in the short, medium, and long term. At the end of the Green Touch project, it was demonstrated that the combination of all these secondary technologies had the potential to reduce by a factor of 10 the energy consumption, and an energy efficiency gain of 254 between 2010 and 2020. This 2054 factor can be decomposed into a factor 10 created by the traffic volume increase between 2010 and 2020, a factor of 2.54 created by the Moore's law, and a factor of 10 thanks to the technology enablers. On this slide, we illustrate a virtual RAN and the different primary and secondary technologies that can be adopted to create energy savings. In this slide, we split the vRAN into 3 technologies: the radio units, the cross-link responsible for the interconnection of the radio units to the virtual distributed units, the virtual distributed units, and the central units. We point different key technologies. For the radio unit, among several enablers, we can cite the sleeping mode, an artificial intelligence for the energy management system when using renewable energies, WDM transceivers for the interconnection networks, liquid cooling for the distributed or central units. We note that the 6G XR project is also investigating microgrids to reduce electricity demand. So in conclusion, we can say that we need to address all the layers of a network for a strong impact. Environmental, societal, and economic criteria driving the sustainable design. Per network segment, we need to act at all the network levels. Here we show examples of what can be done, but not limited. We have the project also to go more in detail, but just some examples. For the access point, we need to go beyond the radio frequency technology and also include optical technologies. For the fixed access, we have to go beyond the incremental evolution of points and envisage secondary technologies to follow the new business model. For RAN and vRAN, including the cloud, we need to act at different levels, and we need to have an heterogeneous approach to take benefit of different primary technologies. For the metro and the core, here the need is for higher capacities. The optical technology remains fundamental to offer optical transparent bypass and reduce indirectly the need for ultra-high capacity switch routers. Finally, there is a need to address responsible artificial intelligence through an identification of the resource that need to be used to minimize its impact at the energy level. Thank you for your kind attention. I will be, of course, open to any questions at the end of the global session. Thank you.
Thank you very much, Dominic. That was excellent, and also thanks to all the speakers that actually keep the time quite nicely. For now, I would hand over to Daniel Hauer from Siemens to give us the customer perspective in this discussion. Daniel, the floor is yours.
Thanks from my side for the invitation. My name is Daniel Hauer. I'm working at Siemens in a research group mainly dealing with the smart grid area. So I'm bringing the customer perspective into that project together with some of my colleagues. I was responsible in the work package 2 of this project for getting a first consolidated description of all the use cases of the verticals within this project. And I want today to show you a little bit about those verticals and use cases we will evaluate within this Sustain 6G project. So as my colleague Dominique just showed this slide at his beginning of the presentation, I'm now focusing not on the sustainable 6G part, but on the 6G for sustainability part. So how can 6G help to get other things, other verticals more sustainable? To give a short context and motivation, so as it is clear also from my colleagues that have presented, mobile network innovations is now driven by the global sustainability goals, moving beyond just the technical performance. And that makes it obvious to use 6G also for sustainability in other domains, offering new ways to enhance economic, social, and environmental benefits for industries. Within the project, we have agreed on 3 critical verticals. It's the energy domain, agricultural, and e-health, 3 very critical infrastructures, domains that are important, that can leverage 6G to significantly reduce the emissions and, of course, also to optimize resource use. Therefore, we need a holistic strategy, or we need holistic strategies and supportive policies, not just the technology. From the customer perspective, what are the motivation behind? We have, of course, global imperatives. We have the climate change, resource scarcity. So there's a rising pressure on companies to reduce carbon emissions and to optimize resource use. We have a regulatory landscape with increasingly stringent sustainability regulations. Of course, there are industry challenges like operational inefficiencies. So there are high energy consumptions, waste generation, and outdated infrastructure, which are very often challenges for the different verticals. And of course, there's innovation pressure. There is the need to integrate digital and sustainable technologies to remain competitive. And of course, there's a strategic motivation behind for most companies. There's a value creation. So sustainability as a driver for innovation, cost reduction, and brand differentiation. And of course, also risk mitigation to proactively reduce the exposure to regulatory or supply chain risks. I would now like to highlight the 3 verticals and the initially proposed 3 use cases per vertical, so in total 9 use cases at the beginning of the project. And I want first to start with a short summary of the 3 different verticals before I want to give an introduction on the different use cases there. So from the agricultural domain, it's mainly about to empower farmers with real-time data-driven tools that improve their productivity and sustainability while bridging the rural digital divide. So the main driving values here are obviously optimized resource use, for example, saving of water, also to enable access to smart farming for small growers, for example, and to promote environmentally responsible practices. And foster synergies between farmers and tech providers. For example, if you think about AI, image data processing that can be used by agricultural process to optimize their operation. All the use cases have also had a first evaluation of the responsible or the important stakeholders within those verticals. The list you can find in our deliverables. It's a very long list for all the verticals, but I try to get you the most important ones. So for the agriculture domain, that's of course the farmers and growers, but also the agricultural machinery operators and technicians, as well as agronomic advisors and data scientists. Again, if you think about AI solutions in the agricultural domain, and of course, agrotech companies and edge cloud service providers for those technologies. The second vertical is the smart grid domain. That's also the one where I come from with my Siemens background, where it's about to create a flexible, resilient, and sustainable energy system that integrates renewables and empowers local energy actors. The main driving values, as we are a critical infrastructure, is of course to ensure the grid stability even under fault conditions and to enable sustainable use of distributed energy resources. As you can imagine, the new energy resources like photovoltaic systems, electromobility are very challenging for the grid, and especially to ensure the stability there. Of course, it's also about optimized infrastructure and the operational costs for the grid operators, for example, and to support the dynamic energy market and demand response. The main stakeholders here are the system operators, so both the transmission and distribution system operators, any kind of flexibility service provider, local energy market operators, the owners of distributed energy resources and prosumers, down to citizens that have a PV system installed, and of course also the regulatory authorities. The third vertical is the e-health domain, where the key message is to deliver high quality personalized healthcare remotely while safeguarding data privacy and enabling equitable access. So the driving values here is, of course, expand the access to healthcare regardless of the location, ensure secure and consent-based data handling, enable new business models and medical competence, and also to reduce travel and resource use in healthcare deliverable. which will be something you will see within the use cases, how we can, for example, reduce travel costs and negative impact of that. Main stakeholders here are the healthcare providers like hospital, clinics, surgeons, but of course also the patients, consumers, and insurers, as well as on the technical side, the medical devices and software companies, and also, of course, regulators and data protection authorities. So these are the three verticals: agricultural, smart grid, and e-health. And within those, we have initially defined 9 use cases. These use cases are now within the project evaluated, divided, split up, reconsolidated, enhanced. We have additional use cases, for example, the MNO perspective that was presented by Berner. So this is an ongoing work in this project. But to give you an idea of those 9 initial use cases, I would like to very shortly describe them to you. So from the agricultural domain, we have the connectivity on demand use case, but the challenge is that smart agriculture in rural areas face a lack of high-speed, reliable connectivity. The solution here would be to have temporary on-demand connectivity that reduces the need for the permanent infrastructure in remote areas. And the use case will deal with that by having a collaborative plug-and-play solution that adapts to diverse environments, boosting the efficiency and the resource management. So it's about getting the connectivity out into the rural areas. The second task is, by the way, the first and the second use case are from John Deere, is task offloading to the edge. So when you have connectivity, when you have AI methods and cameras there, then of course the challenge is to have resource-intensive tasks, for example, image recognition, that are expensive and energy demanding for the devices. The solution would here be to offload the critical processing tasks to nearby edge computing devices or infrastructure. And this should be done by a software managed task prioritization that ensures a secure and low latency communication. The third use case from Quampo is about agricultural data versus information. So here the challenge is that waste agricultural data is difficult to analyze due to the complexity and correlation. A solution here could be a real-time data contextualization and automated decision-making, for example, in that use case for crop management. And that should be done by an AI-driven transformation of the raw data into actionable insights and forecasts into that domain. So these are the 3 agricultural use cases. Coming next, the smart grid use cases. It's, of course, dealing with optimizing the grid but from 3 different perspectives. The first use case from PNET is 6G-enabled grid balancing services. So the challenge is here, like in all smart grid use cases, the grid instability from distributed renewables and electromobility charging while having a real-time balancing of the grid. A solution here is a 6G-enabled distributed communication control infrastructure that orchestrates the diverse distributed energy resources. And that should be done by an AI-supported decision-making and predictive dispatch, leveraging the distributed edge intelligence for those dynamic and real-time coordination of the distributed energy resources, like, for example, batteries or PV systems. The second use case is from Siemens, so that's my use case, is dealing with the resilient grid section operation. So we are more focusing on a higher level from the medium voltage and multiple low voltage grids, and also having a resilient grid operation during communication losses. So the idea is to have a 6G enabled strategy that employs intelligent LV grid units that actively coordinate the flexibilities for a resilient operation. And what we are focusing on is a 6G enabled units that can autonomously cluster to coordinate flexibilities, ensuring grid resilience also during communication failures. So if anything in the grid may it be the electrical grid or the communication grid fails, how can the rest cluster and do some local optimization to still have avoid blackouts and have an optimal grid operation. And the third smart grid use case is then combining 6G and smart grid, so the communication grid and the smart grid. The challenge here is that to provide a flexible and stable power for both the ICT and the grid, while we have those integrated renewable that are very volatile. So the idea here is to have a joint 6G and grid planning that integrates localized renewable microgrids, storages, decentralized coordination for the adaptive energy provisioning. So to jointly optimize the mobile network and smart grid operations together for a cost-effective, and that's done by using AI-driven energy management systems. Last but not least, the e-health domain, also with 3 different use cases. By the way, I forgot the third smart grid use cases from Wings. Now going over to the e-health, we have the first 2 use cases from Politecnico di Torino. The first one is about concurrent pre-operative surgical engineering planning. So the challenge here is that remote surgical planning and training demands real-time, lossless and secure sharing of complex medical data. So for example, virtual reality models that have to be shared. The solution here would be in that use case to have a high accuracy synchronized communication links with dedicated data protection and security. And that should be done by a virtual reality enabled cooperation for enhanced diagnostic treatments and critical decision making. So to bring together people at different places in the world, joining together the experts, the surgeons, the experts together in a virtual environment with the needed requirements for the communication then. The second use case is then about remote rehabilitation assessment. So here the focus is on the rehabilitation that is often inaccessible and costly, especially for remote or mobility limited patients, especially in rural areas, for example. And the solution here would be to have a personalized home-based rehabilitation framework that integrates real-time camera feeds, AI motion assessments, and extended reality for guided exercises. And that should be done by a 6G that powers real-time AI video analysis and extended reality for personalized feedback and remote expert oversight. And finally, the third e-health use case from Qualtech is medical data federation. So the challenge here is the securely sharing and locally processing attested medical data for advanced diagnosis in cloud-based e-health services. Solution would here be the network level medical data federation with built-in data provenance, privacy, and hardware accelerated security. And that should be done by a 6G assisted privacy-aware data federation that enables suite processing through distributed data planes and a secure network slice. So about the medical data federation, this last use case. That's it from the 9 different use cases. I hope I have seen most of my colleagues here in the call. I have not described your use case wrong. Please feel free in the Q&A then to add anything you want to say. But I hope that gives an overview of this quite broad use case landscape we have for our 6G for sustainability topic. I want to conclude with what are we currently doing? What are the next steps? So we have already for all those use cases defined the sustainability needs and technical requirements. You've heard a lot about that, but the 9 use cases have now in the deliverable 2.1 set a preliminary list of sustainability needs. You just see here an example split up in the 3 different pillars, first and second order effects. And based on the goals and needs of each use case, the preliminary ICT requirements were specified. So all the use cases have defined their technical requirements and that will now be taken over by work package 4, for example, to have a deeper look here, find the gaps, what is not possible with current communication technology, what are the interesting gaps for 6G, and that will then be taken up by the following work packages and will be evaluated within the project. So I want to conclude with some key takeaways. So 6G is more than a technology leap. It's a strategic enabler for sustainability across the verticals. We are here mainly focusing on the quite critical verticals, agricultural, smart grid, and e-health, besides the already mentioned M&O perspective, to showcase how 6G can deliver measurable environmental, social, and economic benefits. And yeah, the temporary connectivity, edge computing, resilient communication, AI-driven insights are critical to bridging the gaps in those underserved areas and sectors. Again, these are just examples, the full list where you can find the deliverables. And talking about sustainability in the end, on the sustainability impact, of course, this list again is not complete, but the main things here are about the environmental aspects, reduce CO2 emissions, optimize the resource use, and of course, lower the energy consumption. From the social perspective, to improve the access, for example, to healthcare, digital inclusion in rural areas, if you think about the agricultural use case, and enhance public services, for example, from the smart grid domain, to have reliable, resilient access to energy. And from the economic perspective, it's about cost savings, new business models, and increased operational efficiency that can be leveraged by using 6G within those verticals. With that takeaway, I want to conclude my talk and hand over back to you, Tassos.
Thank you very much, Daniel. So as you see, there is a connection between the different presentations. For example, the application of this categorization of sustainability needs, which is then applied in the different use cases. Now, our next speaker is basically concluding the webinar, and so our last speaker for today is Socrates Barbounakis, a senior solutions architect from Wings ICD, and he will, the floor is yours, Socrates.
Thank you very much, Tasso. Hi, everyone. I'm Socrates Barbounakis. I'm a project manager at Wings. So following the hopefully valuable perspectives shared by the previous speakers and colleagues like me, in this final slot to briefly try to summarize some key messages from our work so far, as reflected in the deliverable D2.2, which is, of course, publicly available and which I had the pleasure to serve as an editor. So if we would like to summarize some key messages, sustained 6G frames the 6G innovation around sustainability goals. So based on specific stakeholder inputs, we are targeting it into specific technical research directions, addressing, of course, environmental, societal, and economic challenges in future networks. Technology should be a lever for sustainability and not a neutral carrier, meaning that we investigate how the 6G enablers can actively contribute to reducing resource consumption, enabling greener services and use cases. Also from the 6G for sustainability aspect, as Maria earlier highlighted. At the same time, it is the use cases that actually shape the agenda, not the other way around. So with a strong vertical input in e-health, agriculture, smart grids, but also beyond, in other verticals beyond the project scope itself, the technical design should be grounded in the real sustainability needs coming from the actual stakeholders. The M&O trade-offs are important, are acknowledged and internalized. So from energy efficiency to cost to coverage and resilience, operator constraints are not something to be considered at the end or afterwards, but are used as drivers actually in our design choices. The system level thinking is essential. So sustainability requires aligning connectivity, compute, control, AI, of course, in order to enable the optimization across layers and actors. And overall, Sustain 6G D2.1, the deliverable, of course, sets the foundation. It's not conclusions. So we have identified common definitions, design principles, methodological blueprints, but this is only the beginning. Overall, what we have achieved in this deliverable, if we would like to summarize the key outcomes, we have created the shared sustainability baseline across the environmental, economic, and societal pillars. We have laid down the aspects of sustainable 6G and 6G for sustainability into the 6 dimensions. We have provided the operator's viewpoint. We have identified the sustainability challenges across the various network segments, also the various requirements coming from the various use cases. So we have tried to map where the biggest gaps and opportunities lie. We have provided early alignment with certain verticals, agriculture, smart grid, and e-health. And this early engagement should ensure that the priorities are guided and come from the real needs, not only by some technology push, of course. And we have also introduced certain trade-offs between the sustainability and performance, as we have recognized and analyzing the D2.1 also that sustainability goals can, of course, conflict with certain KPIs. With regard to strategic recommendations, in order to conclude, of course, this is not possible to capture everything in a few bullet points, so I once more encourage everyone to explore the full document for a more complete picture. But overall, if you would like to highlight some key recommendations, key titles, sustainability KPIs and KPIs must be defined early and integrated into the system design. So this is fundamental. Sustainability requires multi-stakeholder coordination, but also negotiation. So no single actor can drive, of course, the sustainability in 6G alone. Regulatory and standardization activities, of course, must include sustainability dimensions. And last but not least, techno-economic models should account for material, energy, and long-term societal impact. So we need to move beyond short-term efficiency metrics, consider full life cycle impacts from materials and manufacturing to operation and reuse. And with that, I will also conclude my talk, hopefully manage to stay within the 5 minutes slot. So thanks a lot. And
yes, absolutely, Socrates. Thank you very much. We are really very well on time. Now I see 2 topics, or actually 3 topics, but the one is very standard, very straightforward. So the slides will be made available through the website. So we can confirm that. So we can you can go to the Sustain 6G website and download material. But by the way, there is a lot more material, of course, than deliverables and slides. I want to go back to the first question that was directed to Berna, although it has been answered in the chat. Maybe we can have a very short discussion on that, and that is the question that there are a lot of research areas and topics in this whole discussion, and how do we plan to prioritize them and perhaps do that along certain priorities, or not priorities, I'm sorry, certain impacts perhaps. I don't know if you want to explain this a little bit, Berna?
Yes, thanks, Tassos. It's true that there are lots of elements in the landscape, and we have to reduce the set in order to be able to work on it, because it's not feasible that way. And there are several ways to choose that reduced set. One of them is to discuss with the stakeholders and take their priorities. at some point in time, and because they know their priorities better than we do. And also maybe make some educated guesses on the impact. We choose a reduced set based on the impact of those elements on the results. I think this is important. We will take into account this in order to make an intelligent choice of the reduced sets.
Okay, thank you very much, Berna. I see one question from Katrina Petersen from PSE. I'm curious about how we handle contextual variation when assessing KPIs in sustainability by design. So privacy by design has taught us that solutions working well in one jurisdiction can be inadequate elsewhere. How might we build that contextual awareness into our indicator success factors? System rules or technology enabler functions, and then question mark. Now, that is probably a good question for Maria, but I can also answer that if Maria feels not comfortable. Maria?
So you can start, I might add, but...
Okay. Yes, so what we have this, or a similar question, we received a similar question also from our external advisory group, which we have established to discuss these different contexts. And what we learned, in fact, from there is that we certainly need to reinforce a bit the message that we have a European focus, which means that the European values are here the priority. Now, other jurisdictions, of course, are also important because they represent partly very large markets. So they are difficult, of course, to map, as you correctly observed, Katrina, but it is, if you like, for us, a secondary priority to actually do that systematic mapping of these values into the technology enabler selections. I don't know if you want to add here, Maria?
Nothing to add.
Okay. So I hope this answers a bit the question from Katrina, the first question. Now, the second question is a bit longer. Maybe I should actually ask Katrina to actually just open the mic and formulate it. Katrina, can you do that, please?
Yes, I can. So yeah, no, and we can go to other questions first. I didn't know if I was allowed 2 questions. So that's absolutely fair. I was just wondering, because the first presentation, Maria's presentation, talked about the need to engage stakeholders and variations within definitions and the need to clarify the definitions, that sometimes it can go across. And then the other presentations really provided some fabulous technical approaches and considerations, but it was separated from this variation challenge. And so I was just curious, from your guys' work so far, have you found any strategies to balance these two so you can support consistent, the selection of enablers, for example, but across these variations? Because different stakeholders might have different, while the values overall high level at the principle level are the same, what they mean in practice for the stakeholders operationally and what's prioritized within them does differ even across Europe. And so I was just curious what kind of strategies you thought of that we could then learn from for that.
Okay, thanks, Katrina. I will try to make a start here as an answer, but I believe this goes a bit into the direction of Daniel, or maybe Kim can take the word. Now, this is directly linked to the ongoing work to identify the gaps. As Daniel mentioned that we were now in the process of identifying what are the gaps that current technology cannot answer, and what are the gaps, what are the requirements then deriving from these gaps that we need to pass over to the next generation, right, to the 6G. So this, I would clearly say currently we don't have the direct answer to this, but we have identified, if you like, laid out the strategy on trying to address this into doing this mapping of what are the needs and requirements, whether and how they are answered by current technology, and what are the gaps that future technology need to answer, and eventually which research needs to be done still in order to come up with solutions to address these gaps. I don't know if Daniel, you have to add anything, or anyone, I don't know, maybe Maria, Daniel, or even...
I'll just quickly add, it's a little bit related to the previous question, because it's still not clear how the key values and KPIs will be actually used, because it's a new thing. And I see two sides of it. How it's the values-driven technology development, how the technology should, like requirements for the technology that are derived from the values to protect certain things. And then the other side is the use of the technology. How like values also impact the use of that technology. So there are always these two sides, and then we get very interesting insight from those vertical applications from the usage side, which then transfers into requirements for the technology side. And Dominic presented one way of addressing this gap, like requirements for the technology development.
Okay, thank you,
Yes.
Maria.
If I can complete
Sure.
concerning your question, Catherine, I think that you raise a very relevant point. So we have to accept also different KVIs per jurisdictions. So it's an obligation, I would say. And then the question is how we can harmonize the solution, the concrete solutions, to take into account different jurisdictions, to have one solution that can be adapted on some points with respect to these new constraints. I would say that, but I agree, for example, in some countries we have laws that are imposing some technology that we don't see in other countries. So this is clear that we have to take it into account and design a general solution that can be adapted to any jurisdictions. Yes, then concerning the enablers, I would say that there are some deterministic techniques that can be applied directly on the top of, I would say, primary technologies, where we know that we will have a concrete gain at the different level. So this can remove any uncertainty concerning the design of the solution. We have also some uncertainty on some other, when, for example, it is dependent to the traffic load, so we don't have the control. And so this has to be clearly identified through a quantification approach, describing the different case that can be we can see in the field. So it's a complex. I fully agree that it's a complex problem, but we need to be specific. The KVIs can be only for one solution, or we want to target. Sometimes we cannot generalize and put all the KVIs for all the solutions, because it will not be aligned. And so it's a case per case, I would say. I hope that I have an answer to your question.
I just wrote in the chat, thank you very much. I really appreciate all your answers. It's very good food for thought. Thank you.
Thank you so much.
Okay, thank you very much for this insightful discussion. There is one more in the chat, and that's, I would suspect, also for Dominic. Now, we have the expectations that AI will be heavily embedded in the 6G network. So the question is, if this extensive use of AI will indeed increase or decrease sustainability, and whether and how we actually address this dilemma.
Yes, this is also a very relevant question, because artificial intelligence can help also the network to be more sustainable, in particular by managing more efficiently the physical resource of a network. In addition, we need to identify what is its impact also on the network in terms of additional energy consumption, if we look at the energy consumption. So this is a very hot topic, and probably there is a need to think about also regulations in order not to go in the different directions, but have a strategy in order to address key topics directly linked to the artificial intelligence. Just an example, in France, we have a shift project that identified, for example, a dramatic increase of the energy consumption in data centers from the artificial intelligence. And so we have to understand why and how we can react on this. And we have to adapt the network to this in artificial intelligence to minimize also its impact at the energy consumption level. So it's a very complex topic, a lot of things to do around artificial intelligence, since it will be a part of the network of tomorrow. So it is already part of the network of today, but we have to anticipate and provide some optimal solutions. I hope
Yes.
that...
Yes,
yes.
thank you very much, Dominic. I would like to add here that the third use case in the smart grid goes a little bit into that direction by endeavoring to have a bidirectional communication between the smart grid and the network, which basically would allow to understand, the condition of the smart grid dependent on the load that is induced by the ICT infrastructure, and of course vice versa. So this will be at least an awareness in both sides of the coin, whether we can or not decrease the sustainability overall. We still need to find out. I mean, sustainability, let's make it much more concretely. In this case, it is about probably, I would say, of the first order effect on the environment, basically the greenhouse gas emissions that are caused by that. So it is a very complex equation here. We have this on the agenda to address, but again, we probably right now cannot give you a direct answer. Right. Any more answers? Oh, sorry, questions. I don't see anything in the chat. We are very well on time, in fact, so we have 2 minutes to 3 minutes to go to close the webinar. Considering that there are no more discussion items, no raised hands, no other questions on the chat, I will present one final slide, and that is just information. Let me find my sharing button. Yes. So this is information that is all contained in deliverable 2.1. Here is a concrete reference to the deliverable, which is available in Zenodo. Here you find the link, of course, directly in Zenodo, but also on the website of the Sustain 6G project. I have included the direct link to the public deliverables, to the collection of public deliverables, which is obviously currently not very well populated, because that's indeed the first really heavy content-wise deliverable available from the project. And of course, the link to the main sustain6g.eu site. Now, I saw one more comment in the chat. Let me. Okay, maybe Costa, could you please take the floor and explain what you write, because it's a lot that you wrote.
Hi, Tassa. Yeah, sorry. I was just trying to add some context to some of the very last question that was asked about that Dominic touched upon. How do we balance the greenhouse gas emissions that we expend now, or the energy that we expend now, in order to save greenhouse gas emissions in the future? So, for example, if we were to implement a particular feature or investment that releases X amount of greenhouse gases now, in order to save maybe 10 times that in 1, 2, 3 years' time, there are some models that are kind of existing out there that try to incorporate some of that thinking within a kind of a return on investment framework. So just the way you do a return on investment on money, you can do a return on investment on greenhouse gas or on energy. So if you can spend, 10 gigawatts today to save 200 gigawatts tomorrow, then that might be a way to start thinking about sustainable investments of return on investment for sustainability. I haven't done a lot of research on that, but it might be worth doing something as part of that conversation, especially since we are potentially looking at sort of building smart grid infrastructures, for example, which have a cost in embodied carbon. So if we're going to do that to save some, I'm sure somebody's already thinking about these in the right task. I'm sure I think in discussions people have mentioned similar models.
Right. Okay. Thank you very much, Costa. Now I just want to stop you here because we are over time now. So I already presented, in fact, the closing slide, and I would like now formally to close the webinar to conclude the webinar here. Thank you very much all for joining this webinar and for your attention. And please follow us on the different social media channels for updates that will come in a faster pace actually in the next couple of weeks and months. Thank you very much, and the webinar is closed.